today we'll be continuing from our previous video, that is carbohydrates. So today we'll be discussing about open chain structure of glucose. So in our previous video, I have told you about glucose exists in open chain structure as well as in cyclic form. So today we will be discussing what are the evidences that proves that glucose can exist in cyclic form as well as open chain structure. So first we'll be discussing about open chain structure. The first one that we have is its molecular formula. The molecular formula of glucose is what? Molecular formula. The molecular formula of glucose, as you all know, is C6H12O6. So this is one of the evidences of the structure of glucose. Okay, that is open chain. Now we'll be discussing other points which are very important. Please listen carefully. So number 2, presence of 6 straight carbon chain. Now this, we saw that in the open structure of glucose, these 6 carbons were in a straight chain. Now what is the evidence for this? So the evidence is this. See, whenever glucose, that is CHOH whole 4. So this is carbon number 1. Rest of the carbon from carbon 2 to carbon 5 contains all OH group, that is second degree OH group. Therefore I have written it as a whole 4. Please, this is also one of the way how we can write glucose. Okay, and CH2OH. So whenever glucose was treated with HI and heated for a long period, what we obtain is N-hexane, that is CH2, 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 CH2 and CH2. 1, 2, 3, 4, 5, 6. So this is N-hexane, and this reaction proves that these 6 carbons in glucose, they are in a straight chain. Okay. The third point that we will be discussing is presence of carbonyl group. Okay. See, we know the open chain structure of glucose. So from the structure, open chain structure, we are going to show the evidence for presence of C double bond O group, C double bond O, that is H. Okay, attached to H, that is aldehyde group, as well as there are different OH groups, second degree, primary, all these things will be proved here. Okay, and this shows the 6 carbons stay in a straight chain. The third point we are going to prove is presence of carbonyl group. Okay, so this, that means we have C double bond O group, presence of C double bond O group. Now here, whenever same glucose is treated with hydroxylamine, okay, so let me write CH2, CH2OH whole 4, CH2OH. This is the structure of glucose. Whenever it is treated with hydroxylamine, that is NH2OH, what will happen? This is CH double bond O, or water molecule will be removed, as we have discussed in our chapter carbonyl compound. Okay, so what we obtain is oxime. Okay, we obtain what? Oxime. So we have CH. So H2 from here, and this oxygen will be removed. As a result, you will be having double bond NOH and rest of the carbons CHOH. So here you have only one hydrogen, OH, whole 4 and CH2OH. So the reaction has taken place only at carbon number 1. So this is what? This is an oxygen. And this is a characteristic reaction given by carbon group. Okay? So this shows that in this glucose we have carbonyl group. Now let's discuss about the fourth point, that is presence of aldehyde group. The fourth evidence is presence of an aldehyde group. Presence of an aldehyde group, that is C-O-OH. So this is the presence of this aldehyde group. So which reaction shows the presence of aldehyde group? Now let me write the structure of glucose. It is CHOH whole 4 CH2OH. Now whenever glucose is treated with bromine water is a mild oxidizing agent, and you know aldehyde group is very sensitive. Therefore, this bromine water will oxidize the CHO group to COOH group. So we will be getting COOH, CHOH, whole 4 CH2OH. So this aldehyde group has been converted to carboxylic group, and this is known as what? Gluconic acid. And this reaction given by glucose with bromine water shows that the carbon group that is present in glucose is aldehyde group. Okay? Had it been ketonic group, that would not have been oxidized. So let me tell you, this is a test which is used to distinguish glucose from fructose. So fructose has ketonic group, glucose has aldehyde group. Therefore, whenever you are asked a test to differentiate between glucose and fructose, then this test with bromine water can return to distinguish between glucose and fructose. So now let's discuss about the fifth point, presence of 5 hydroxyl groups. Presence of 5 hydroxyl group. Now you know this glucose contains 4 OH here and 1 OH plus. So we have 5 OH groups. So how can you show that glucose contains 5 OH groups? That can be done by treating it with acetic anhydride. CH2OH, and here it is 4. Okay? So whenever you treat glucose with acetic anhydride, I hope you still remember the formula of acetic anhydride. We had discussed it before. CH3. So whenever glucose is treated with acetic anhydride, then all the OH will be substituted by this acetate part. As a result, we get how many? How many OH groups are there? 4 plus 1, 5. So we get pentaacetate. Means this acetate will replace all the 5 OH groups. So let me write the structure. CH2, CH, O, C, double bond O, CH3. This is whole 4, and here we have CH2O C double bond O CH3. Now we get what? This is penta-acetate. Now since we get penta-acetate, whenever we treat glucose with acetic anhydride, therefore we can say that in glucose there are how many OH groups? There are 5 OH groups. Okay? Now among this, as I told you in the beginning, 4 of them are second degree OH groups, and the last one, that is the OH group that is attached to the 6th carbon, is a first degree alcohol group, OH group. So let's discuss about a test which shows that the OH group that is attached to the 6th carbon is a first degree OH group. So we have presence of first degree alcohol. Okay? The 6th point is presence of first degree, that is CH2OH group. First degree alcohol. Now we know the structure of glucose: CHO, CHOH, and I'm telling it once again, all these 4 OH groups are what? Second degree alcoholic group. Now the OH group that is attached here to the 6th carbon is first degree. So whenever we oxidize this with nitric acid, HNO3, then what will happen? Nitric acid oxidizes this first degree alcohol to COOH group. Please remember this. Okay? And this does not oxidize the second degree OH group. So OH group will not react with it. Only the first degree alcohol will be oxidized to COOH group. And obviously CHO is more reactive, and this will also be converted to COOH group. Okay, so let me write the product. COOH in the first carbon, the remaining second degree alcohol, that is OH group, will be remaining as it is, and it is only the first degree alcohol which is present in carbon number 6 will be oxidized to carboxylic acid. So please look at this very carefully. And the name of this compound is saccharic acid. Saccharic acid. So these 6 reactions, evidences proves that glucose exists in what? This open chain structure form. And in our previous video we had discussed about glucose staying in cyclic form also. So let's discuss that too. Now we are going to discuss about cyclic structure of glucose. Okay, so the first point is that, say, some of the reactions given by this glucose shows that it contains CHO group, but it doesn't give certain reactions of aldehydic group. For example, in spite of the presence of CHO group in glucose does not give 2,4-DNP test and 6 test. So it doesn't give, it means glucose does not give 2,4-DNP tests and this shows that the aldehyde group, okay, once it stays in cyclic form, CH2 group is not free. So therefore it doesn't give this test. Number two is what? The pentacetates of glucose does not react with hydroxylamine, indicating the absence of free CH2 group. So what did I say? The pentaacetate of glucose does not react with hydroxylamine, okay? Hydroxylamine, which shows that again the CH2 group in glucose is not free. Number 3, as we have discussed before, alpha D glucose and beta D glucose. Now glucose, there are evidences which shows that glucose exists in alpha form. Presence of alpha D glucose, and it can be obtained by crystallizing it at 303 Kelvin. And also number 1 is alpha D glucose, number 2 is beta D glucose. Now this can be again obtained by crystallization of concentrated solution of glucose at 371 Kelvin. So these 3 points, okay, shows that glucose exists in cyclic form. So to conclude, we can say that whenever glucose is kept, okay, then some of it will be existing in open chain structure and some of it will be existing in this cyclic form. Therefore, we conclude that in glucose we have both open chain form as well as cyclic form. So that's the end of today's class. Thank you.